select an appropriate sample or subjects for our study, let's look into details on how to design our experiment and some related terminology. In this section, we're going to talk about the 3 most common experimental designs, though there are many more designs in varying complexity for those designs. So the terminology, you've seen some of this or you're familiar with some of it already. We have this idea of our subjects or experimental units. The way to think about that is the who or what is receiving the treatment in the study. Who or what is being assigned to groups. The response, we've seen that before. There's our outcome variable, the effect variable. Our factors, you can think of that as our cause or explanatory variable. Those that were curious, how do those different factors affect the response or the outcome? Then we have factor levels. Those are actually the possible categories for the factor. So be very careful in the distinctions here on these last 3. Factor is just the variable name itself, and the levels are actually giving the details of it, the categories of it. Then the treatments are all combinations of the factor levels in the study. This distinction, you might not see what I mean until we're on the last example, but another way to think about treatments is every possible combination that could be assigned to your subjects or experimental units. So make sure you're comfortable with this terminology. Let's check out our first and most simple design, the single factor design. In this design, we have only one factor, as the name suggests, in the study. A little side note here, the levels and treatments are the same when we have a single factor, and you'll see in our example. So in this example, we have a physician comparing weight loss for 3 different types of diet, and we'll just call those diets A, B, and C. We have 30 middle-aged women participating in this study, and 10 are randomly assigned to each diet, and we're measuring weight loss in pounds after a 3-month period. So our experimental units, the who or what that are being assigned to groups in our study, are our 30 middle-aged women. The response in our study is that outcome variable. What are we measuring? And they tell us here we're measuring weight loss in pounds after a 3-month period. So I'll just say weight loss, and they're measuring that in pounds. Next, our factor. What is that variable that's going to affect the response? What will affect weight loss? Don't give all the details, just what is the variable name? So in this case, they say that they're interested in the effects of diet on weight loss. Now, factor levels, you can give the details. So they don't give us a lot of details. They just call them diets A, B, and C. So those are my levels, or the different types of diet in this study. The treatment is all the different combination, what my subjects might be receiving. Since this is such a simple design, my 30 middle-aged women are going to be receiving one of the 3 diets, A, B, and C, which was our note up here. If you have that factor levels and treatments are the same when you only have one factor in the study. The last thing we're going to jot down is a nice efficient way to summarize this study. The first thing we always need to include in these outlines are our subjects. Who's participating in the study? Then we show how they're broken into groups in the middle of the study, and this is how it varies from different type of study. And then the last part we always want to include is our response. What are we comparing? What's that outcome variable we're measuring at the end of the study? So that's kind of a summary of what these outlines should look like. So in our particular example, the subjects in this study are our middle-aged women, and we have 30 of them. So if you know how many, jot it down in parentheses. If you don't know how many, no big deal, don't write it down. So our subjects are the 30 women in this study. Next, we need to say how they're divided into groups. So they tell us that they're going to be randomly assigned to one of our three diets, diet A, B, or C. And in the paragraph, they tell us that they'll be assigned equally 10 in each group. They also mentioned that the way they will be assigned is with random assignment. So I'm going to put RA above these branches here and make a little note at the bottom down here that RA means randomly assigned. Now you don't need to put this note all the time. Just put it on the first one so we know, you remember what that RA means. So our 30 women are randomly assigned 10 into each of those three diets. Then the last part of our outline should be our response. What are we comparing among those groups? So they tell us at the end of the study that they're going to compare or measure weight loss at the end of this study in pounds for these women. So there's our outline of the study. So this is the most simple design, and let me just give you a heads up. If your outline starts to look really complicated with a lot of lines on it, you're probably doing something wrong. It should be very simple. Who, how they're in groups, and response. And you don't need to draw individual lines for every single subject in your study. Okay, let's check out the second variation on this, our multi-factor design. And in this class, we're going to focus on specifically by multi-factor, we're just going to stop at 2 factors, but it could be more than 2 factors. So instead of just looking at one variable affecting the response, we'll look at several, 2 in our case. So paragraph's going to look real familiar. We're still comparing weight loss for 3 types of diet called ABC, but now we're going to also check out 2 exercise programs. We'll call them E1 and E2. And we have our 30 middle-aged women again. 5 are going to be randomly assigned to each combination of diet and exercise. So our experimental units are still the women, 30 of them. Our response is still going to be weight loss in pounds at the end of the study period. Our factor, now we have 2 things of interest, 2 variables, diet, and we're adding to that exercise. Okay, notice factor is just the variable names. Don't give any more details than that. When you're working through your homework and other places, make sure you're really clear that you know the difference in those definitions between factor, the levels of the factor, and treatments. So factor is the variable, or variables in this case. Levels give the details. So the factor of diet has 3 levels. A, B, and C are our types of diet. The factor of exercise has 2 levels, exercise program 1 and exercise program 2. Now, before, factor levels and treatments were the same in our 1 factor example. Now they're no longer the same. Treatments are all possible combinations your subjects might receive. So I have 3 types of diet, and I'm looking at all the different combinations with the 2 types of exercise. So 3 times 2, I've got 6 different treatment combinations. You can label them if you like. Treatment 1 might be diet A with exercise 1. Treatment 2 might be diet A with exercise 2, and so on. Treatment 3, let's check out diet B with each of the exercise programs. And then finally, we'll check out our last 2 treatments as diet C with each of the exercise programs. So our treatments again are all the different combinations of the factor levels. Now our outline is going to start in much the same way. This time we have a few options though. We always need to start with who is in the study, so our women are the subjects. Again, we know that there are 30 of them. Then we need to show how they're broken into groups. So one way we could do that, the problem tells us that 5 women were assigned to each possible combination of diet and exercise. So I have these 6 combinations. And so 1, 2, 3, 4, 5, 6. And since I labeled them nicely up here, to keep my writing short, I'll just call them T1 to T6 down here. And it says they were randomly assigned, so don't forget to put that RA. My 30 women were randomly assigned to one of these 6 combinations of diet and exercise. Finally, I'm going to close this off with my response. What am I comparing? What outcome am I comparing among these different treatments? And that was weight loss in pounds. This is one possible way to draw the outline here. By the way, some people ask, can you flip this horizontally and draw it top down? Totally fine, same information. Another option for this that is also correct would start the same way with our 30 women. There's no options there. You always have to say your subjects, who they are, how they're divided into groups. So this grouping I could write a bit differently. I could say maybe they were divided into the 3 diets, A, B, and C, with 10 in each. And then once they've been divided into their 3 diets, I can show how they've been divided into their different exercise programs. 5 in exercise program 1 with diet A, and 5 in exercise program 2. And so on. And this conveys the same information as the previous plot. The result is 5 in each of these different combinations. And we're still going to close it off with our response of weight loss. Now, a quick comment here. I've purposely left something out. I don't know if anybody's caught on to that yet. If you're saying in your head or maybe out loud, RA, you're correct. We need to also make sure to denote that we randomly assign to these groups. And you'll see why that's so important in the last variation here. There's a third way, which I'm not going to take the time to draw out, but maybe you can guess it. Instead of having the diet programs first, you could have this 15 in exercise 1, 15 in exercise 2, and then break off in the 3 diets. That would also be a perfectly fine arrangement for this outline. So far we have 1 factor, we have 2 factors. The last one we're going to look at is this not 3 factors, design 3, which is our block design. So in the block design, it kind of has properties of both of the previous 2. But the key idea here is we're interested in one particular factor, but there's this second factor that we need to take into consideration. It's often thought of as a nuisance factor, this other variable that usually cannot be randomized, but it's going to influence our results. As a side example here, suppose I was doing a study to look at the effectiveness of different methods for stopping smoking. So maybe patch, gum, several different methods. So that's my factor of interest, is the method for quitting. However, whether someone quits or not may also be strongly influenced as to whether they live with someone who smokes or not. So your roommate situation, for example, that I cannot randomly assign, at least easily, I cannot do that. And it's going to influence the results. And I'm not really interested in the effects of living with a smoker or non-smoker. I just want to get at the idea of the different methods. So that whether you live with a roommate or not, that would be a nuisance factor that I need to take into consideration. It's not something I can randomize. And those variables are called our block variables. Those secondary factors we have to account for and typically cannot randomize. So let's look at our example one last time with another variation. So still comparing weight loss for 3 types of diet. This time I've got 15 men and 15 women in the study. 5 men were randomly assigned to each diet, 5 women to each diet, and we're interested in the effects of diet. Okay, so that says very clearly what my factor of interest is. Then it says, by the way, the sex of an individual may influence the results. So men might respond one way to this different diets, and females might respond a different way to the diets. I need to account for that, but really I'm interested in the diets themselves. So here, our experimental units are 30 adults. The response, or my outcome measure, is still weight loss in pounds at the end of the study period. My factor of interest, we just mentioned up here, we are interested in the effects of diet. So my factor of interest is diet, and then I don't ask for it, but let's add it, why not? Our factor levels are still those A, B, and C. And then our treatments, those things we can randomly assign, are the 3 diets A, B, and C. Our block, or that nuisance factor that we need to account for, is the sex of an individual. It's going to influence the results, but we can't randomly assign it. And then finally, our outline for this study. If you have a block experiment, then you need to make sure the block goes first when you're breaking it into groups. So I'll say block goes first in the grouping. Otherwise, the approach is going to be much the same. We're going to start off with who's in our study. So we have our adults. There are 30 of them. And then for our grouping, we need to put our block first. So they tell us we've got 15 males and 15 females in this study. So I'll denote that first. Next, we need to say how they were assigned to those different treatments. So we've got men being assigned to the 3 diets, women being assigned to the 3 diets, and 5 in each. Notice, use parentheses with a number. Don't draw individual lines for each individual subject in the study. That would get very hectic looking and take way too much time. And then finally, we're going to close it off. This is also a slight difference, so pay attention here. We're going to close it off with within each block. We think males might respond differently than females, so we're going to compare the diets within each block here. So we're going to check out weight loss, or the effectiveness of the diets for this first block of males, and then weight loss, or the effectiveness of the diets for this second block of females. Now again, I purposely left something off to make sure you're thinking. Hopefully you're thinking RA, and you want to be careful. We're not going to randomly assign the sex of an individual, so leave that alone. But once we have those blocks, we are going to randomly assign diet within each of those blocks.